रजनी को हेलो 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 गुड मॉर्निंग
Good morning.
हाँ
Good morning, sir.
Good morning. Okay, others are joining already. We will start. Acha, have you submitted the laboratory quiz?
No, sir.
क्यों? Why?
Yes, sir. স্যার দেবো, আমার একটু শরীরটা খারাপ ছিল, আমি দেবো।
আচ্ছা ঠিক আছে, আজকের মধ্যে দিতে হবে, আজকের মধ্যে।
হ্যাঁ স্যার, দিয়ে দেবো।
ঠিক আছে, এমনিতে সহজ তো সব, কুইজ তোমার জানা সব তো।
হ্যাঁ স্যার।
বাস, very good. Already I have seen around 50 students have submitted. Total number of students in your class, how much? How many?
74 to 136.
Total how many? Around 60, 65?
হুম।
65.
ল্যাটারাল আছে তারপর।
So around 20 people, 20 to 18 to 20 people not yet submitted. You not only submit yourself, you should tell others to submit. Okay. So today evening I will put the marks, maybe in I think 6 or 5, and then once C1 is completed, then it will be locked. Then you can see the marks as far as I have given the quiz. On the basis of quiz, I will give 30 marks. At 10 marks, generally I used to take viva, but this time viva is not possible. So whatever assignment I have given every day to day, those who have submitted regularly, on the basis of that I will give 10 marks in laboratory also. Okay, because laboratory
Yes.
viva I will not take. On the basis of that I will give 10 marks, and on the basis of this quiz I will give 30 marks. So total in this way I will give 40 marks. Okay. So
Yes, sir.
have you seen UGC notification? I will send you the UGC notification. There everything, all probabilities are there, right? All possibilities are they have written, right? We can conduct test for 2 hours. We can have internal assessment. So they have explored different possibilities and everything is mentioned. But without assessment, marks will not be given. That is also mentioned. Okay, this was
স্যার
tell me.
আগের দিনের পিডিএফটাতে একটা কোশ্চেন লাস্টে বাকি ছিল না?
কি বাকি ছিল না? ও আচ্ছা, ওইটা আগের দিনের পিডিএফটা না? আচ্ছা আচ্ছা।
হ্যাঁ।
Okay, let us check. Let me go to that. I think this question, right?
একেবারে লাস্টে।
In this question, probably the last one, I think, this question.
স্যার ওই যেটা ডাইরেক্ট কনভলিউশন করেছেন না, ওখানে একটা না 3 মিস হয়ে গেছে আপনার।
কোথায় বলো তো? এই আগেরটাতে না এটাতে?
না না, ওই 5 দিয়ে যেটা করেছিলেন n is
এইটা
equal to 5,
এইটা
n is equal হ্যাঁ এই যে 5 3 3
এখানে
এখানে হবে
একটা
একটা একটা।
তিন মিস হয়েছে, তাই তো? ও লিখে নেবে।
হ্যাঁ স্যার। হ্যাঁ
এখানে এখানে আছে তো?
হ্যাঁ স্যার।
তাহলে ঠিক আছে। ওকে, বাট আচ্ছা, have you understood all this? Not an issue, na? Everything okay? This particular problem, there is a, I think I have to discuss. So what is
Yes, sir.
there in this? We have taken m equal to 3. M equal to 3 means it is given m equal to 3 because 3 points. So m minus 1 equal to 2, all right. Now I have assumed n equal to 4. If I assume n equal to 4, then I can calculate L equal to 2 because 2 plus L. Now you have to introduce 2 zeros. So 2 zeros I have introduced, 7 6 I have taken here. Then 7 6 here, 4 5 is here, then 4 5 is here, 2 4 is here, so 5 2 is here. Next I said this is after 3 nothing is there, so I will add 0. Then I will take 3 0 here and all 0. Now what is the problem in this? Since you have inserted 3 zeros in the last element, you are supposed to insert 2 0, but you have now 3 0. And in x5 of n, you are having one additional 0 because there is no element. Then what I have said, everything will be same, like circular convolution of each xi of n with hn you have to perform. Once you perform this, then I said, then you have to exclude last 0. Hello? আমি ক্লাসে আছি, ক্লাসটা শেষ হোক, তারপর 11:30 ফোন করো। Okay, so now what is the problem in this? Suppose if I have impulse response having 3 points, so that is equal to your 0 to 2, right? 0 to 2, and this is your 0 to 8, right? 0 to 8 or 7, 1 2 3 4 5 6 7 8 9, so 0 to 8. So total it has to be 0 to 10. So you will be having 11 elements, right?
Yes, sir.
So 1 2 3 4 5 6 7 8 9 10 11. So 11 ends here. So you don't require this element 0. Now what my point is, suppose if you have any signal existing on some specific point, say 0 to 10, but after 0 to 10, if you insert 10 number of zeros, that is not an issue. Not an issue. That will not change the signal, right? If you add signal, after signal, if you add 0 or exclude 0, include 0, after signal, not an issue. But if you insert signal, if you insert 0 in the before or the beginning of the signal, then this will be issue because that will shift the signal right of the right side. So this will shift the signal right side means if I insert 0 at the beginning. So insertion of 0 at the beginning will shift the signal in the right side, and shifting of signal in time domain, corresponding effect in the frequency domain, you will be getting additional phase. Additional phase.
Sir.
If the signal is shifted in time domain, what is the effect? Additional phase will be introduced. I have discussed in many example probably, and properties also. Any shifting, circular shift, linear shift, that will introduce additional phase in the frequency domain or Z domain. In Z domain also, if you have seen that n minus n naught means Z to the power minus n naught into x of Z, right? Right, Z to the, and Z equal to what? R into e power j omega, right? So e power minus j, if in case of Fourier transform, if we talk about R equal to 1, so x of n minus n naught, if you take Fourier transform, e power minus j omega n naught into x of omega. Are you following what I am saying?
Yes, sir.
So if I shift the signal in the time domain, then that will introduce additional phase in the frequency domain, Z domain, S domain, whatever be the domain in DFT also. So shifting signal means if you are inserting 0 at the beginning, that will shift the signal. Therefore, there is a change in the signal. If signal phase is different, then there will be different. signal, on output will be different. So insertion of 0 is at the beginning is a problem, but whether you insert 0 at the end of a signal or if you remove a 0 from the end of the signal, that will not change the signal at all. And here, since you know that after linear convolution, number of element has to be 11, 0 to 10, if you have one additional element from the process, because you are supposed to take 9, 0, then you can omit the last one. Or if you write the last one, that is also not a mistake. But if somebody counts on the basis of what do you call linear convolution rule, then this is a problem. Therefore, I suggest remove 0. You write 7, 20, 37, 31, 24, 23, 19, 24, 22, 12, and 9. All right. I hope now this is complete the explanation. Agreed?
লাস্ট এলিমেন্টটা সব ক্ষেত্রে 0ই হয়
নো, সব ক্ষেত্রে হবে না, সব ক্ষেত্রে হবে না। এই পার্টিকুলার ক্ষেত্রটাতে হচ্ছে যখন তোমার ধরো ওখানে তিনটে এলিমেন্ট আছে, তোমার টোটাল ওখানে 9টা আছে, কিন্তু আমি দুটো দুটো করে নিচ্ছি, সেইরকম ক্ষেত্রতে অ্যারাইজ করবে। মানে ওখানে ধরো 9 elements are there in your X of n, you are taking 2, therefore 4 into 2 8, so one element extra, you are introducing 0 in the last one pair. See, this is the situation arising due to the fact when this kind of situation will arise. If this is the question, I'll answer that too. You are taking 2 of this 2, this 2, this 2, but their 2 pair is not there. Then you are inserting additional 0 for the sake of procedure of the problem. If you are inserting additional 0 here, then in last one you are now having 3 zeros. If you are having 3 zeros in a situation, then you have to omit the last 0, because you are having additional element compared to the required number of element. Required number of element, if you are having suppose say 0 to 8 in your xn and hn 0 to 2, you are supposed to have 0 to 10, 11 elements. Now if you are getting 12 elements, then 12th element you have to discard, right? So this will be the situation that will be arising due to this factor. Any doubt? If you have any question, you can ask. No question, I think so. Fine. So like that, I have solved, I think overlap and add method is easier. I have solved two examples, but overlap same method I have given at least 4 5 examples. So with this you should be in a position to any of this, because whatever be the university questions or other university questions I have come across, and I find that we should have a solution for that. I have tried to solve this, and this I have given. Okay. So if you look at the different question paper, then you will see that whatever be the question asked so far, that will come either of this category, whatever problem I have discussed in this 2 sections. Okay. Now I would like to proceed further if you have no doubts. Okay. Now next topic that I have to start today, that is fast Fourier transform. Fast Fourier transform. So what I will assume before starting this discussion, that you are comfortable with GFT. Okay. Are you comfortable with GFT? Huh?
Yes.
Fine. If you are comfortable with GFT, then we want to start FFT, fast Fourier transform. Now, first of all, we will try to learn what is fast Fourier transform. Now, I have already mentioned that topics started from DFT to FFT filter design. These 3 sections are new to the course, and DFT you have understood. If you have understood DFT, then this will be a continuation topic of FFT. Now, first of all, why FFT is needed? While discussing DFT, I mentioned that DFT has larger computational complexity, right? So that computational complexity, what I understand, that number of multiplication required, of course, complex multiplication, and number of complex addition required, that could be large if the data is large. Now, this is the definition of DFT: x of k n equal to 0 to n minus 1, x of n w n k n. This is the definition of n point DFT. N point DFT. Now, what is this n? What is this n, capital N? This n is essentially, we have discussed during DFT, this n is essentially, if I go to that topic of DFT,
Number of point in
number of points in the
signal.
no,
Input signal.
no,
Number of points on the circle.
number of points on the
Impulse.
circle, number of point in the circle in the frequency domain. This is the correct answer. Yes, Ananya probably correct. Ananya correct? Now
Yes,
let me go to that page which I have discussed. Number of points in the circle. And what Amit is said, he is also correct. He is also correct in some sense. I will tell you why Amit is correct, but perfect answer is Ananya. I will discuss both the aspects. Very important aspect. Both the aspects are important, so I will discuss both of them. Where actually that page is there, where I have started DFT. Here, probably, yes, this is here.
yes.
This point is n, number of points in this is n, right? Here we can n equal to 4 here, this n equal to 4, then this is n equal to 4. Agreed? So number of frequency samples is n. Now let me answer why Amit is said number of point in the frequency. Because we have solved several problems of 4-point DFT. And I have given many assignments to solve 4-point DFT in which xn is having 4 points. Agreed? Xn
Yes.
is having 4 points. So
Yes,
it
sir.
means that 4 points in the signal, and I'm asking for 4-point DFT, it may seems to that xn is having 4 points. But the case is that n refers to number of frequency sample. Now, when number of point in the signal is 4, what I essentially say, length of the signal is 4, is not it? Length of the signal is 4. Now, if length of the signal is 4 and your 4-point DFT, sometimes it may be like, it feels like the number of point in the signal that decide number of points, but no, it is number of point in the frequency sample or on the circle. But the thing is that length of the signal that has to be less than equal to n. N means number of point in the frequency sample. If I ask you 4-point DFT, then your length of the signal that has to be maximum 4. It could be 2, it could be 3. It cannot be more than 4. In one class, probably Amit, you have asked why sir length is 4. Maximum length is 4. Do you remember? Then I said that the length of the signal has to be less than that of n. N is essentially frequency domain samples. That means if you have signal having 2 points, signal having 3 points, signal having 4 points, means signal length 2, 3, 4, 1, 2, 3, 4, you can find 4-point DFT. Then if you ask why, if signal having 5 point, then why it is not possible? Do you have a question like this?
Then what's
Suppose I am saying that length of the signal, suppose I am talking about 4-point DFT, and 4-point DFT, I understand the number of samples in the frequency domain on the circle, omega. Then I am saying the length of the signal could be 1, could be 2, could be 3, could be 4, but not more than 4 if I am asking for 4-point DFT. If I am asking for 4 points DFT, then this computation is possible or valid if the signal length is 1, signal length is 2, signal length is 3, signal length is 4, but not more than 4.
yes, sir.
Signal length not more than 4, then only we can compute 4-point DFT. This is the statement, that length of the signal L has to be less than or equal to n. Now my question is, do you have a question why?
Yes, sir.
Yes. Others? Or others may have the answer. Why length cannot be more than 4? Why length cannot be more than 4? Okay. Now let me say, suppose you are having 4 points. 4 points in this. Okay. 4 points in this. Now going to the today's list. So what I have so far, I will explain why this has to be maximum 4. That I will explain. So far we have got what is the essence of n. Now let us go to the today's lecture. There we will discuss. Now suppose this is your equation of DFT. Now I am considering n equal to 4, means 4-point DFT. Then 0, 1, 2, 3. So this is your equation of xk. This will be your equation of xk.
Yes.
Yes, sir.
Now suppose signal is having another point. Another point means if the signal is having another point.
4
If the signal is having
omega 4, okay.
so omega 4, then if it is omega 4, then what will be the coefficient?
4 omega 4 4k.
Now suppose if I have, suppose say x4 omega to the power 4k. Now suppose in your axis, if I come here, this is your omega 40. Omega 40 means 1. This is 1. Omega 41 means, omega 41 means omega 41. Suppose k equal to omega 41. Omega 41 mane koto?
0.
Look, omega 41. Omega 41 mane koto? So from circle. How do you say from the circle which one is omega 4? 1.
K equals 1.
No, this is omega 40. Next one is where how I have discussed this now in one lecture.
Yes, sir.
Where? Say here.
Minus j.
Correct. This is omega 40. This is omega 40, right? Next one
Yes,
is
sir.
omega 41. This is omega 42.
Anti-clockwise, sir.
This is omega 43. Then this will be omega 4. If I are having, suppose say another point x4. তাহলে x4 into omega 4 হবে তাহলে if you are having omega, suppose x0, x1, x2, x3. Now suppose if you have another point another point if I have, then what happened? Suppose omega x1 I am calculating. Omega 40, omega 41 with x1, x2 omega 42, x3 omega 43. Then I have 0, 1, 2, 3, 4 points in the circle is completed. 4 point in the circle required because it is 4-point DFT. Now suppose if you have another point will be x4, w4 to the power 4. Achha, w4,
Yes.
achha, w4 4 to the power 4, that will be which point? w4 to the power 0?
1.
Yes. তাহলে কি হবে? 2 points are overlapping.
Each other.
2
Yes.
are overlapping. Now, in case of 2-point overlapping in a frequency domain, 2 spectrum overlapping, 2 spectrum sample overlapping, this phenomena is known as aliasing.
Yes.
Aliasing, you have studied in your
Yes.
sampling. That
Sampling.
spectrum is overlapping. Here, 2 spectrum means frequency sample is overlapping. This is known as aliasing. And aliasing has to be avoided. Therefore, if we have more than 4 points in the signal, then 2 points will be coinciding, and therefore there is a frequency domain aliasing. In order to avoid that aliasing, you require the length of the signal has to be less than n, where n is the number of points in the DFT or number of samples in the frequency domain. Agreed?
Yes, sir.
So this explains the questions. So 4-point DFT does not mean number of points in the signal. However, if you say that 4-point DFT means maximum number of points in the signal, that could be 4, or length of the signal could be at most 4, this is correct statement. That's why I said Amit was partially correct. Because if I say it is a 4-point DFT, maximum number of signal points, that could be 4, or length of the signal could be at most 4, that I can say. But the best way to answer this is number of samples in the frequency domain. I hope this is clear.
Yes.
Very good. Very good. Very important understanding. Now let us look into the topic. We are slowly entering into the topic. So what I have written that x of k n equal to 0 to n minus 1 xn w and kn, where w equal to e power minus j 2 pi and w and kn equal to j 2 pi by n kn. Everything is all right. Now suppose n equal to 4, then this is my equation. X of k and substituted n equal to 0 to n minus 1. Suppose this is n-point DFT. So if it is n-point DFT, then I will write 0 to n minus 1. So 0 to n minus 1 means you are having n number of points. Right, n-point DFT, number of frequency sample, this decides this summation n equal to 0 to n minus 1. That is the frequency samples. And maximum that is possible as per this equation n equal to 3, because n equal to 0 to 3. Now if I write this equation substituting x0, x1, x2, x3. Now I am writing your k equal to 0 to n minus 1, so x0, x1, x2, x3. Now in each steps, this step, how many addition is there?
3.
3.
3.
Number of complex multiplication is 4. So
4.
total number of addition is 4 into 3, 12, which in general n into n minus 1.
N minus
N
1.
is the n-point DFT, n-point DFT, and total number of multiplication is 16, n into n, because each step you are having 4 complex multiplication. If I'm talking about multiplication, then this is of course complex multiplication. Now my point is, for n equal to 4, this is 16 and 12 multiplication addition. Now what I understood from these two, a equal to n, this equation of addition and multiplication, which essentially gives you the computational complexity. So what I can at most at this stage understand, that if my n is large, then number of addition requirement is large. If my n is large, then number of multiplication required that will also very large. And if I am working for or looking for reduction of computational complexity, what I understand that I want to reduce the number of addition as well as number of multiplication. If I want to reduce the number of addition and number of multiplication, what essentially I have to do? I have to reduce the value of n. Reduce the value of n. If I reduce the value of n, then I can reduce the computational complexity, means number of addition, number of multiplication. Okay, from this what I understand this equation. Now for 8 point, I require 56 number of addition, 64 number of multiplication. Suppose n equal to 1000 samples in frequency domain, and 1000 sample frequency domain means signal length could be at most 1000. But in practice, that is Mbps or Gbps modern days, but Gbps system is not over here, mostly Mbps systems. So Mbps system number of bits per second is 10 to the power 6, order of 10 to the power 6. So 10 to the power 6 is number of samples. So that multiplication will be very, very large, right? So computational complexity very, very large. Therefore, what is the conclusion at this stage? I was mentioning, to reduce computational complexity, that is number of addition and multiplication, we have to reduce n. I hope this, so far this discussion is all right.
Yes, sir.
Fine. Now you are given, suppose a question in which you are having 8 points. So if you are having 8 points in the question, that means you are asking for compute 8 point DFT, n equal to 8. N equal to 8 point DFT means your xk, that will be x1, x2, x0, x1, x2 up to x7.
Yes, sir.
So
Yes, sir.
the question is, you are supposed to compute 8 point DFT, then you should have the answer x0 up to x7. Now, two things at this stage. First of all, if I am asked, if we are asking for say 8 point DFT you have to compute, then I should have an answer x0, x1, x2 up to x7. That answer we cannot alter. Second thing, that what I have understood from the estimation of computational complexity, that if I reduce the point, then it will be lesser computational complexity. Suppose if I have minimum computational complexity, then it will be, suppose we have only 2 points. What is the computational complexity? 4 square and 2 into 2 minus 1, 2. We require how many addition? 2 addition, 4 multiplication, right? Therefore, there is an algorithm that is called radix 2 first Fourier transform algorithm. Radix 2 means, suppose if I have a number, say 8 points, then 8 or maybe anything, if I express nearby 2 to the power something, then this will be m equal to 3. M equal to 3 means I have 3 computational stages. I will compute in 3 stages. However, I will be obtaining the DFT only for n equal to 2. N equal to 2. What I mean?
Repeat once.
So what I'm saying, whatever be the point of DFT, suppose n equal to 8 or any other number, I have to express in 2 power m, nearby 2 power m sometimes. Then I have to obtain value of m. From this value of m, what I understand, the number of stages in the computation. However, I will compute only 2 point DFT. What I mean, suppose you are having x0 up to x7. So I have to choose the appropriate combination, not that x0, x1, x2, like that. I have to choose this appropriate combination and we'll make a pair of 2. Pair of 2. So how I will be having how many pairs? I will be having 4 such pairs. x0 to x7, if I am pairing 2, so I will be having 4 such pairs. So 4 such pairs, I will compute 2-point DFT. So 2-point DFT if I compute, then I will be having 4 multiplication each computation and 2 addition. So total 4 pairs, I will be having 4 into 4, 16 multiplication, 8 addition. This is reasonably less compared to this 66 and 64. Now, if somehow what I have obtained 2-point DFT of this pair of 2 and 4 such pair, if I can combine this result by some means to obtain x0 to x7, then that will be having lesser computational complexity. So at this stage, what I have understood, that computational complexity in DFT is essentially dependent on it is what point DFT. If it is n-point DFT, n into n-1 is the addition and n square is the multiplication. From this addition and multiplication equation, it seems to me that somehow, if I reduce the value n during DFT computation, then combine the result obtained in lower value of n, then if I combine this result by some means so that I can get the result of xk, x0 to x7, then I will be in a position to reduce the computational complexity. In other words, number of multiplication and number of addition. Agreed?
Yes, sir.
Anybody having any doubt, you can ask.
Sir, 2-point DFT কেন বের করছে? দুটো করে পেয়ার।
দুটো পয়েন্ট না হলে তো দুটো পয়েন্ট তো মিনিমাম, আদারওয়াইজ ওইটাই ডিএফটি যে পয়েন্টটা আসবে।
না স্যার, 3টে 4টে তো নিয়ে যায়, মানে বেশিও তো নিয়ে।
তাহলে তো আবার মাল্টিপ্লিকেশন তো বেড়ে গেল, ওটা তো n into n-1 n স্কয়ার। তাহলে আমি 3 করলে 3 into 3-1, দেন এটা হচ্ছে 3 স্কয়ার, বেড়ে গেল তো। আমি চাইছি যে যতটা কম হয়, ধরো যদি একটাই পয়েন্ট থাকে, একটাই পয়েন্ট হলে সেটাই ডিএফটি, ওটা কিছু করার নেই, তাই না? একটাই পয়েন্ট দিয়ে দেখো প্রথম রোটা আর প্রথম কলামটাতে তো সব 1, বুঝতে পেরেছো? প্রথম রো আর প্রথম কলামটা যদি দেখো, যদি একটাই পয়েন্ট থাকে তাহলে কম্পিউটেশনটা কি দাঁড়াচ্ছে? শুধু x0, বাকি কোনোটাই নেই। তাহলে এইগুলো কোনো এক্সন শব্দ নেই, তাহলে কম্পিউট কার করবে? একটারই ডিএফটি হবে, x সেটাই হয়ে গেল। তাহলে আমার একের বেশি হতেই হবে, তো আমি 2 নিলাম। 3 কেন নয়? 3 হলে আবার 3 into 3-1 3 স্কয়ার। 3 into 3-1 ভ্যালুটা যেটা হবে সেটা অবশ্যই বেশি হবে 2 into 2-1 এর থেকে। বাইরে বুঝতে পারলে? তাহলে আমি লোয়েস্ট লেভেলে ডিএফটির কম্পিউটেশনটা করব। লোয়েস্ট লেভেলে যদি আমি ডিএফটি কম্পিউটেশনটা করি, দিয়ে সেই রেজাল্টগুলো কম্বাইন করতে আমার অ্যাডিশন মাল্টিপ্লিকেশন লাগবে, সেটা লাগবে। কিন্তু আমি দেখব আলটিমেটলি দ্যাট ইজ রিলেটিভলি লেস compared to n into n-1 and n square. This is the target of this algorithm. Okay?
Yes.
So at this stage, what I have understood that I have to reduce the computational complexity of a given problem. So instead of computing the endpoint, I have to reduce to lesser number of points so that I can compute such thing, and ultimately I can have the lesser computational complexity. So we have discussed up to this today. I am having less than 1 minute, so I will start from here. Okay, so what I have understood, I have to reduce n and I have to compute 2-point DFT and I have to combine this result, then I have to get the final output. Okay, So with this, I would like to close. I am having less than 1 minute left. So what I want to say that you should submit the laboratory assignment by today, 4:30. This is
Yes,
required.
sir.
Okay. So we will again meet
Yes, sir.
4:30 and we will continue from here. Okay. Until then.
Okay, sir.
Done
Thank
it.
you, sir.
Thank you, sir.